One of the big questions we get asked at BirdDog support is, how do I set up the network for this thing to work? People don't really care what the answer is. They just kind of want to know what the answer is. And so that's what this video is all about. We want to tell you the basic requirements for just getting up and running with BirdDog NDI. And there are various ways of doing this, and we will talk about those various ways in a little bit. But today, right now, let's talk about, I want to get up and running. I want to plug my cameras in and get going. What do I need to know about the network side to get this started? First and foremost, we need a network that can do DHCP, flat out. Put aside the idea that static is easier. It's not, and we'll talk about why that is in a later video. But DHCP needs to be enabled on this network in order for this to work. We need to set those, if we really need to know what the IP addresses are of each of the devices on the network, if that's a level of control that you need, then we use the DHCP reservation list to do that. And that is a place where we put in the MAC address and we associate an IP address with it, but the DHCP still issues those. What happens is the device joins the network. It says, here I am, I need an IP address, here's my MAC address. The DHCP service will look up their list and say, yes, that MAC address is on here, and they need to be issued this IP address. I am currently running that configuration in this studio right now on the camera you're watching, okay? The DHCP issues the same address to this camera every time I power it on. Doesn't matter where I plug it in, as long as I'm on my NDI subnet, it happens every time. So it works great. It's a good way to achieve that goal, but it has a lot of benefits in this configuration, which I'll talk about in just a minute. Okay, so the next thing we need to do is set our DHCP timeout to 60 seconds or more. This part isn't as critical as it used to be, but sometimes DHCP services, especially older routers, they take a little longer to process the broadcast requests. Modern day networks is not necessarily the case, but in older style things, that is the case, older style units. And so increasing that DHCP timeout a little bit longer on the cameras, okay, that's at the camera level. We changed that to about 60. That helps us be sure that we waited long enough for a DHCP response to come back before it goes to its fallback address. We need to have managed switches, not smart managed and not unmanaged. We need to have managed switches, Netgear 4250, 4350, whatever you like there, but a managed switch that is layer 2 at least. Now, the Netgear 4250 is actually a layer 3. We'll talk about that later, but a layered managed switch that is not a smart managed or an unmanaged switch. We need to configure 22255 or a single subnet design. So in the subnet mask, it needs to say 255, 255, 255.0. This will give us over 200 IP addresses for our NDI network. Okay, that's plenty. If you're pushing anything past 20, we're going to be talking about multicast pretty fast. So a 22255 WAC 24 is really all you're going to need in a unicast environment. If we're going to multicast, this is kind of irrelevant, this piece. A lot of the reason why we say DHCP is because MDNS is required. And if it's required for NDI. And if you're going to go static, you need to figure out how to either manually manage your MDNS on your network. It has to be on and active, or you need to be using a discovery server, which we will talk about in the static configuration video. But discovery server is another customizable step which has a fail point problem that you're going to have to address. And so MDNS is required, or discovery server is required when you're running in static. And so in DHCP, it's not, and it's included in when you turn on a DHCP service, and MDNS is generally also included as well at the gateway level. You need to also be planning a gigabit network through the entire installation. No 10100s, okay? You should have the option to operate at 10100, but you should not be issuing any switches that are doing 10100 or any network cards on computers that are doing 10100. Gigabit is going to be required always, and so that's where you start. That's the baseline level of what switches you're going to buy. They're all going to be 1 gig ports at least, okay? We need to be using Cat 5e or Cat 6 standards. Okay, let's not go to Cat 7. Let's not go crazy here. Cat 5e or Cat 6 standards. So 6, 6a, whatever you like. but you definitely need to work on those two protocols. And we need to turn off all power conservation options on our networking devices. And so if you're using PoE, you need to turn off triple EE, which is the power conservation standard, or you need to turn off green Ethernet, because what's happening there is the switch is so smart that it's learning what your average consumption is. And it actually needs to do this for things like VoIP phones and security cameras. But with PTZs, we need variable PoE. And it generally, when you're talking about the BirdDog P240, or you're talking about like the P400 or something like that, it's going to vary. It's going to operate and idle at probably PoE standards, but the motors are going to be required to operate at PoE plus standards when it is moving. And so the switch can't learn, because most of the time the PTZ is going to be sitting at idle. Okay, it's not moving all the time that it's on. And so it's going to, we can't let the switch learn what its average drawdown is, because it's going to put it in a PoE category and then fail to deliver when it's time to move the camera head. So we need to turn off power conservation unless you're using an AV line specific switch like the Netgear 42 or 4350s. All right. In addition to this, we also need to be able to have the option, per the new tech guidelines, we need to have the option to have turn off jumbo frames and to turn off QoS, quality of service. Okay, we need to be able to turn those functions off. QoS is, for a lack of a better term, basically packet inspection, which will introduce latency or drop frames and do a bunch of weird things to your video. You need to be able to turn off QoS, and you need to be able to turn off jumbo frames. Okay, we don't want jumbo frames. Those network guidelines can be provided to you, by the way, through the BirdDog support team at help@birddog.tv. Just reach out to them and say, can I please have the network guidelines? I will also include them in the coursework here for this video. The other thing is that there is an NDI technical brief that you can kind of go over that talks about some of this ideal stuff as well. Okay. So if we're setting up a basic network, let's talk about the highlights. A DHCP service with a WAC24 subnet. That'll give you over 200 IP addresses to operate in your NDI environment. We strongly recommend that you use an NDI VLAN, okay, to isolate the NDI traffic in its own network on your greater network installation, unless you're buying switches to isolate, like old school, and you're just going to run all NDI off of its own switching hardware. Okay, that's fine too, but most instances you're going to use the same switches for multiple functions. So we want an NDI VLAN, that's DHCP, that's WAC24, that has MDNS up and running and good to go. That is a gigabit network, and that turns off, that you have the option to turn off power conservation if you're using the PoE function for cameras and converters, okay? In general, that's the fastest way to get started, and you'll have great performance if you follow those guidelines.